Hi to all, this is J. Oblish, Assistant Professor, Department of Computer Science Engineering, Anurag Group of Institutions, Hyderabad. These slides reveal the basics of process. Before going to discuss about the basics of process, I want to introduce some related terms. First one is a program. Program is nothing but collection of instructions. Another one is a file. After typing the program, once we save it, that entire program will be saved in hard disk. In that case, that program itself we are calling it as a file. After that, if we execute that program will be transferred from hard disk to RAM. Why? Because for executing of any program, the program should be resided in RAM. In this case here, once we execute any program, that will be transferred from hard disk to RAM. In this case, that program we are calling it as a process. That's why here, what I said here, any file or program which is in RAM, that is a random access memory. So, for understanding about these three terms, I gave some example like engineering student means the student who is currently doing engineering. In that case, we may call it as a process. A file, in the sense, student with empty rank is waiting for execution, waiting for doing engineering, This is what exactly the relation between three terms. That is a program, file, and process. Yeah. First of all, what exactly the definition of this process? Process is nothing but a program which is in execution is called as a process. As I said earlier, for executing any program, that should be in RAM. That's why a file or a program which is currently executing, that's what we are calling as a process. Here I mentioned some examples. First one is a file which is a double click. Once you double click, it means the file should be in execution. And another one, a file which is given to printer. If we given to the printer, that is also called as a process. Player which is playing, any media player or a VLC player which is currently running, which is currently playing, that is also called as a process. Now, I want to clarify what exactly the program and what is the process. With respect to user point of view, program may consist of a header file, data, and instructions. Once you save it, that will be stored in hard disk. Once we execute it, that will be transferred into RAM. There and what we are calling it as a process. Within the computer system, the operating system can store the information of the program in these four categories. One is the text data, and text data heap stack. The program code is also called as a text section. Current activity including program counter, processing register, all this information will be stored in text area. Stack containing temporary data, that means function parameters, the return address, the local variables. That means within the program, whatever the parameters we use or whatever the local variables that will be used in this program, that will be stored in stack area. Data section containing global variables. That means within the program, before main, whatever the variables we declared, that variables we are calling it as a global variable, that global variables will be stored in data area. Next, heap, containing memory dynamically allocated during runtime. While executing the program, whatever the memory that is allocated dynamically, that information will be stored in heap. So, user point of view, the program is nothing but this, but with respect to operating system point of view, that program should look like this. Now, next important feature of process is process control block. It is also called as a task control block. Operating system maintains one PCB for one process. That means, if there are n number of processes in operating system, OS maintains n number of PCBs. That means one PCB for one process. Complete information about the process is stored in PCB. For example, confidence group. That means regarding student, whatever the information that is there, that information will be stored in one book or a file, what we call it as. That means at what time he joined, what is the information of the student, how many subjects he passed, how many backlogs he has, and everything we are storing in one place. That place what I call it is counseling book. Similarly, operating system also maintains one PCB for one process. These are the contents of the PCB. Then the PCB holds process state, running state and waiting state, program counter, CPU registers, CPU scheduling information, memory management information, accounting information, IO status information. All these information that will be stored in PCB. Next important point is states of the process. Any process after its creation, that process should be any one of these 5 states. First one is a new state, ready state, running state, waiting state, and terminate state. For understanding this scenario, here I am giving one good example, that is a hospital scenario. Initially all the patients are there, that's what I call it a new state. Once all the patients are in hospital with a token, that's the state what I call it the ready state. Once the token is granted, then the patient will be entering into after row. That state what I call it is the running state. After checking, if the doctor need any blood report or urine report, at the time the patient will be entered into waiting state. That means that in waiting state, the patient should be waiting for the reports. When patient 1 is waiting for the reports, patient 2 will be entering into doctor room. If patient 2 also need any report, again he also enter into a waiting state. At the time, patient 3 will be entered into doctor room. Here, either patient 1 or patient 2, if anybody got his report, then he will be entering into ready state. Thereafter, he will be again entering into doctor room. Once the patient diagnosis is completed, he will be entering into terminated state. This is a complete diagram. If any process is after creation, that will be in new state, that will be admitted in ready state here, then that will be selected by the dispatcher, that will be entering into running state. If any interrupt is occurred, immediately the process will be entering into ready state. If the process execution is completed, then the process will be entering into terminated state. If a process need any IO value, then it will be entered into waiting state. After getting of input value, again it will be entered into ready queue. These are the complete states of the process. Thank you for your hearing. Thank you.